We're here at Wye Cylinders and they are over the moon in their recent investment of an automation cell. So Ash, what's the story here? Why did Wye Cylinders come to yourselves?
We were given the task to improve productivity and improve on the current process of the way that they were machining it and automating those particular components.
Right, okay, so what was it that they were machining? What was the negatives? Where was the problem?
The products that they were machining weren't particularly difficult. It was more about getting the right machinery and the right solution for their own product, so they manufacture their own product.
So I know that the company were making particular parts, but the machine that they were using was an old machine and it had so much downtime, it kept on breaking down.
Yeah, we're told they lost 6 to 8 weeks of every year with downtime, so
wow.
We had to make sure that was actually a more stable process and a more reliable product.
Okay, so what was the brief next? What did they say, this is what we need?
We were asked to automate for 14 hours unmanned.
Right, okay. Is that then the night shift?
Yeah, effectively that's, yeah, so from the end of the day shift to the next new night shift, yeah, effectively, yeah.
And what were they doing before?
Either the machine wasn't reliable, so it might even stop from time to time, or they just didn't have the capacity within the gantry loaders that they were using to actually have the raw material stop, if you like.
And I know from James, who's the CNC manager, they had a lot of scrap. That's what he told me earlier. That doesn't give them any confidence, does it really?
No, and I think a lot of the time with the type of machine that they've got, they've been able to eliminate that. So probing, swarf management, and ensuring that is a stable process. So the robot will complement the machine in that way.
Okay, what was the process then that you offered? You got a nice Mazak here as well, the Integrex.
Yep, so we've provided it's called the Turn-assist 270. So the stocker table behind me there holds 270mm maximum diameter. We've got a 35 kilogram payload robot, and the finished parts, as you can see, are going to the pallet there, so they don't have to be handled again.
And so did you tick box there 14 hours? Have you done exactly what they've said?
Yeah, I mean, it's only been in for a few months, but the best they've had is a full 24-hour run.
Oh, really?
Yeah. And
I know their return on investment is massive here, like they're really impressed with it.
Yeah, so with the robot itself, we're looking at a return on investment in just months.
So now I think the door's perfect, changing over cycles. Tell me what the process is, Ash.
So the basics of what we're seeing here is the robot will now unload the finished part from the sub-spindle. The robot will always give it an air blow, as you've just seen there, to clean the part before and after he takes the part, so pick and place.
Right.
Then we're going to reload the main spindle with the raw billet, as you can see with the second head that the robot has. So the robot has 2 heads, one for the raw, one for the finish, because you will be gripping onto 2 different dimensions. The robot that we've got in this position, in this actual installation, is a 35 kilogram payload. So we can lift some decent sized billets with it. The table that we're picking and placing from, so where you can see the raw material stocker is within the cell. That is where you place your raw material and your finished parts come back to the pallet. Now the principle of that turn-assist table, as we call it, has a maximum of 270mm diameter on there, and you can stack your raw billets on there.
It's interesting because you can stack your raw billets on, and on the interface, the screen here, it can tell you how long you've got left of that process as well, haven't you?
Yeah, correct. So the robot software will know the cycle time of your parts, and it will know how many parts you've got on the stocker, therefore what time you're going to finish.
And why in particular went for the Mazak as well? Because of the tool change?
Yep, so what we needed from the Mazak was a small footprint, and what was needed from the robot as well was a small footprint. So we needed to stay within the confines of the machine, and the cell had to be a certain depth to suit the environment that it was in, so walkways, pump trucks,
and they couldn't go gantry because of height issues here.
Yeah, and in this actual example, the robot cell is a lot smaller than the gantry.
Well, they went from 1 building and now they've gone to 3, and this isn't the only automation that they have from yourselves, is it?
No, so they've had an existing robot which handles shafts up to 80mm diameter, 1.5 meters long at its maximum. So they've had that for a few years. Now this is the second purchase, and there is a third on order due in the coming months.
So I know that they're blown away by this. Their return on investment they're so happy with. They've upskilled their team members. They've got their weekends back. They're not having to pay for people at weekends. And they've got the unmanned run. They are over the moon. So Ash, what would you say to anyone who's in a similar position to Wye to go for this as a sell or automation in general?
If you manufacture your own product and you don't automate, I think you need to. Otherwise, you're looking at you're doing the same old process over and over, and you want to put margin back into your product. But if you manufacture your own product, it enables you to plan better. It enables you to schedule better.
Yes.
You know you can order your raw material in better batch sizes, and it enables a fluid process from the raw material in to the finished parts out at the end of the door.
And there's just so many positives.
Wye Cylinders have never had so much production from one machine like this before. It's a no-brainer.